What we'd like to do now is to see how to use Excel to compute probabilities involving normal distributions. And what I'm going to try to do is I'm going to split my screen here for a second. And I'm going to show you a really nice little online tool and try to tie together what we're doing in Excel with the pictures that we looked at in class of the normal distribution. So we can kind of make this connection between probabilities and areas for percentiles. So in the book, on page 140, was it 148? We were trying to find the percentile of a certain IQ. So I'm going to go ahead and I'm going to put the data value. So we were looking at IQ, which has a mean of 100, and it has a standard deviation of 16. And we wanted to know, what is the percentile for a person that has an IQ of 90? And let me just kind of just increase this a little bit in size so it's a little easier to see for you guys. Okay. All right. And what I'm going to do is I'm going to use this online calculator. There's a site called Online Statbook. It has a calculator for normal distribution, but it also gives you this kind of nice picture too. So let's go ahead and look at a normal distribution. It has a mean of 100, standard deviation of 16. Okay. And I want to know what is the percentile for 90? So I want to know the percentile below the data value of 90. Okay. And I probably have to hit a little. Oh, I have to toggle this. There we go. Okay. And I'm going to go ahead and compute it here. And we see that the answer is 0.266. Okay, and this is the area here, 26.6%. The whole area under the tail's 100. The whole area under the curve is 100%. So we see that percentile is the area in the left-hand tail, and that's 26.6%. How would we compute this in Excel? Well, we're going to use the norm.dist command. So there's norm.dist. There's my data value, there's the mean, there's the standard deviation, and we're always going to say true, okay, for cumulative. In other words, it's the percentile is accumulating the probability up to that point. You can think about it that way. And we see we get basically the same value rounded to, you know, the nearest third decimal place. So that's how we use norm.dist to get the probability in the lower tail. What if I wanted the upper percentile? Well, all I would do is I would just subtract 1 from that. There is not an Excel command for this, okay? So we have to do this by hand. So 1 minus the lower percentile, and that would be my upper percentile. Of course, I'm going to round these guys off. I'm going to express them as percentages just because it's a little easier for us. So we'll format this really quick. And there we go. And of course, if I did hit this here and I did 90, what you would see now is you would see the area above the tail. Above the value. So you see the area in the right-hand tail. And sure enough, you see that value is around 73.4%. Okay. So upper percentiles are areas in the right-hand tail. Percentiles are areas in the left-hand tail. What if we now wanted to look at, say, an IQ of 130? So that was another question in the book. Notice I can just drag this right down. Should my answer be less than or greater than 50%? Let's think about this, okay? Well, this is the mean, right? 130 is about 2 standard deviations above. So we should think that this is going to be in a pretty high percentile. In fact, if we use the empirical rule, right? 2 standard deviations, values within 2 standard deviations contain 95% of the values. So there's 5% in both tails, 2.5% in each tail. So this should be roughly around 97%, right? Somewhere around there. Let's just see what we get. Sure enough. And now if I ask what percentage of values are below 130, and watch the area in the curve. So you'll see right here, this value will be chosen, and what will be shaded is in the area in the left-hand tail. And there we go. And of course, we get the same answer. Again, the upper percentile is going to be roughly in the upper 2.5 percentile, right, around the 3rd percentile. Okay, good. Now, what if we want to go backwards? So very often we want to go the other way. We want to know, okay, if we're given a percentile, what value corresponds to that? So let's use the problem in the book. We wanted to find out what the IQ was for a person in the 25th percentile. So I have to enter 0.25. I got to be a little careful here, and actually I have to reformat these values. When you enter a value in Excel as a percentile, it has to be in decimal form. Okay? So I'm going to go down here, and I'm going to say norm.inv. Notice I'm going the other way, right? The inverse is the other way. You're giving me the percentile. You're telling me basically what is the area in the left-hand tail, and I'm finding the value that has that area in its tail. So norm.inv is the command I want. I'm going to click here because it's kind of obscured by the values here. Okay, and that's all that I need. Oops, no, it isn't. Oh, my bad. I didn't enter the first value. So you have to enter the probability or the percentile in decimal form, okay? Then you need to enter the mean, then you need to enter the standard deviation. 89.2. And let's see if I can do this here. I'm not sure if it will let me do this. I don't think it will, no. Actually, it won't let me go backwards. It won't let me give the area. But I can check this, right? If I want to, I'll just type in 89.208. And I should find that it's roughly 25%, and I do. Okay. I don't think this will work if it's an actual percentage. Let me just check really quick. Maybe it will. Let's see. Okay, it will. Yeah, Excel it does interpret percentages as decimals internally, so it would still end up working. So let's go ahead and do that. Do that really quick. So let's say, for example, we wanted the person who's in the upper 25th percentile. Now we got to be a little careful, right? Because the upper 25th percentile is what percentile? It's the 75th percentile, right? So now if I went and I redid this calculation, I'm working with the same distribution, right? So the mean and the standard deviation are the same. And I repeat this calculation, I'll find out it's 110.7. And these values actually, if you sit down and you look at this carefully and draw this out, you'll find out they're the same distance from the mean. And that makes sense. This has 25% in its upper tail. This has 25% in its lower tail. So these should be equidistant due to the symmetry of the normal distribution. All right, that's pretty much all there is. The last thing I'll mention is standard normal really quick. So with standard normal, it's kind of interesting because we don't have to specify the mean and the standard deviation. So with a standard normal, by definition, its mean is 0, its standard deviation ends up being 1. So let me go ahead and type a percentile. Let's say we wanted the 45th percentile. I'm going to format these all as percentages just really quick. Oh, come on. And of course, I have to go back and change this to decimal. There we go. And I want the z-score for the 45th percentile. There's a special command. Instead of using norm.inv, I can use norm.s.inv. And all I have to do is enter the cell where the percentile is, which in this case is B8. I'm just going to enter it by hand. And it gives me the value. And it makes sense because we know the 50th percentile is 0. So if I'm less than 50%, this should be the z-score. And we can check that really quick. This is what a standard normal distribution looks like. If I type in this z-score, I should see the area is 45%. And I can go backwards. Let's say, for example, I have a z-score of 1.25. I can use norm.dist, but again, I'm going to use a special version of it, norm.s.dist, so I don't have to bother entering the mean and the standard deviation and all that stuff. I still have to put cumulative. Okay. Whoops, I'm sorry, true. And there we go. And again, this makes sense, right? If I have a z-score of 1.25, I'm above 50%, and you can work that all out. I'll put it in really quick so you can see. And sure enough, we get our answer. So this shows you how to do calculations involving normal distribution, and we're going to be doing this a lot. In fact, all of hypothesis tests, when we get to the end of the process, is going to boil down to doing these calculations. So it's important you master this. What people get messed up on is remembering which norm command to use, norm.dist or norm.inv. If you don't remember, and when I first started off, I didn't use Excel a great deal. I didn't remember. You can try one. And the cool thing about Excel is it will tell you immediately if you're on the right track. So let's suppose, for example, I want to go from a data value to a percentile. Whoops. Go back here. I can start typing something. Okay. So I can start typing norm.dist. And notice the first thing it asked me for X. It's asking me for a data value. So that tells me immediately what direction I'm going from. I'm going from a value of X to a percentile. Okay, so you can always try out one. The other thing that gets people messed up is when we're talking about upper percentile. So remember that if we're given an upper percentile, we have to convert it to a lower percentile and then use norm.inv to get the data value. In the same way, if I want the upper percentile, I have to use norm.dist with Excel to get the percentile and then convert it to an upper percentile, just like we did. And if you master those two things, it's a piece of cake.